Hi! Data architectures usually consist of 5 layers. These are first, data producers, second, the data ingestion layer, third, data storage layer, fourth, data processing layer, and fifth, usually multiple data consumers. In this video, we'll briefly present these 5 layers and talk about some of their key characteristics. Let's start.
Nonlinear AI.
Let's start by looking at the first layer, the data producers. Every company has a plethora of data sources. Some examples include application databases. These might contain user details, item details, or past purchases. Most companies have other internal systems such as CRM, ERP, or PMS systems which contain valuable information. Nowadays, client applications track the behavior of the users. Which button did they click? Which items did they spend time on watching? IoT devices generate sensoric data. Often, third-party datasets are used to train and test machine learning models. Data can be broadly categorized into 3 types of structure. In the past, we had a lot of structured data. So this is basically tabular data. Nowadays, we have a lot of semi-structured data. So for example, JSON or XML files. Nowadays, we have also lots of unstructured data, such as rich media like audio, video, or images. What about the frequency data might be produced at? Usually there are 2 types. The first one is so-called batch data. Batch data is generated in periodic intervals. So, for example, every hour, every day, or quarterly. Some examples include database dumps or third-party datasets. The second type of frequency is so-called stream data. Here, data is generated continuously. Some examples include online behavioral tracking, so whenever a user is surfing a website, the data is constantly sent, or sensoric data coming from IoT devices. As you have seen, most companies have many data sources. These live usually in different systems or even in different departments. So what you want to do is bring all this data together, preventing data silos. In order to do this, you use a data ingestion layer. Let's look at what this is. We saw that data might be produced batch-wise. For that, our ingestion layer should also be able to ingest batch data. This is usually pull-based. So what that means is that the ingestion layer will pull the data from the sources. For that, ingestion layers usually have connectors to popular databases and services such as PostgreSQL or third-party tools like Google Analytics. On the other hand, we saw that data can be produced constantly in a streaming way. For that, our ingestion layer should be able to handle stream data as well. Usually this is push-based, so the data producers push the data to the ingestion layer. Some properties we want to have is that the system should have low latency, because usually you use push-based or streaming data when you want to have near real-time capabilities. The whole architecture should be scalable and, most importantly, fault-tolerant. Now that we have looked at data sources and the ingestion layer, the question is, where does the data go? So usually we want to have a central data storage to bring all the data together in one spot. Let's dive deeper into this data storage. There are a lot of systems to store data. For data architectures, however, we want systems which fulfill some key properties. Let's look at some examples. You can imagine that bringing in data from various sources leads to huge data sizes. Our data storage should therefore be able to scale with the data. On the other hand, it's important that the data is available all the time. Thus, the system should be reliable. Machines will fail. However, we must not lose any data. The system should therefore be fault-tolerant. Company data is very sensitive. The whole system should therefore be secure. Even within the company, we want to have full control over who is able to access which data. The system should therefore be access managed via authorization and authentication. Now that we ingested and stored all data sources into a central place, we want to process this data. Examples include cleaning, transforming, joining the data, as well as to compute additional features. The data processing layer should therefore have some key properties. Since data can arrive in batch or streaming, the processing layer should also be able to process data either in batch or streaming fashion. Again, the whole system should be able to scale to big data. This includes volume, the frequency, as well as the structure of the data. In other words, we need to be able to process data of any size, form, and frequency. The processing layer should ideally provide various access paradigms on the data, such as a SQL interface or full programming support for various languages. Excellent! We are able to ingest data, to store data in a central place, and to process that data. But why are we doing this? Exactly, we have multiple data consumers. Let's look at some examples. One of the most prominent examples is business intelligence. Here you try to build dashboards to monitor key performance indicators and metrics. Another application is analytics, where you try to answer ad hoc data queries, such as how many users have seen our marketing in Brazil, or how many users have dropped out after signing up for our trial. Another application is reporting. This is interesting for some businesses such as finance. Nowadays, machine learning is very important. Some examples include building recommender systems, or optimizing the search ranking, optimizing the stream ranking, fraud detection, predictive maintenance, customer churn prediction, ETA predictions, and so on and so forth. We will see many more machine learning applications in the future. We can also build other data-driven applications, such as customer-facing dashboards, or real-time status updates towards the customer, as well as showing some statistics on the website, such as number of followers or number of likes. Great! We've seen that modern data architectures usually consist of 5 layers. The first layer are the data producers. The second layer ingests data from various sources into the third layer, which is a central data storage. The fourth layer enables processing of the data in the central storage. The final layer are various data consumers, such as machine learning applications, business intelligence, or analytics. It's important to keep in mind that there is no silver bullet. A company's data architecture might vary depending on factors such as the company size, the data producers, and consumers. I hope that this video still helped to get a better understanding of what data architectures look like. Take care and see you next time.